So today we are doing problem I already got at an interview, online assessment for IBM 435 or I think something like this. Non-overlapping intervals, given array of intervals, return mean number you need to remove to make the rest of the intervals non-overlapping. Now the intervals which only touch at a point are not overlapping, so 1, 2 and 2, 3 are not overlapping. So I mean, first intuition is, we can flip this, and what's the max number we could take, right? And then we could do like number of intervals minus max we can take, and we would do that in a way by sorting ends, and then we pick wait, so because okay, what's the problem, right? If we just pick the soonest ending one, right? I mean, I'm not sure that's good, so I guess what we can do is if we sort by ends, right, and then we do DP, and that's minimum we need to remove from first I to make them non-overlapping, assuming we take that one. And if we take that one, right, we have to like skip some of them, I guess. So we can binary search to how many we want to skip, and then we take maximum over that, right? So or minimum. So what I'm thinking is that, okay, so let's say I sort by ends, right, and then I'm at whatever, this one, right, and then I can use anything that ends at 2 or less, right, because something that ends at more than 2 I cannot take, right, so we have to skip those, and from the rest of them we take the one that technically that's the maximum number of them, right, and plus that single one, and we can keep like prefix maximum, and then answer is n minus that maximum, what I was talking about. Let's see, so sort, I don't want to call it intervals, bro. Ints let's call it like auto x, auto y, otherwise I say it doesn't matter. and we have to binary search. Because if we sort by ends, stars don't have to be like increasing or decreasing or monotonic, right? So meaning that we cannot use 2 pointers. Anyways, we got the intervals, bn, right? And then initialize to 1. And minus gp and minus 1, right? And then we do r is equal to so we take midpoint. I do +1 because I pre-think that intervals 0 is smaller than or equal to ints I1, then L is M, right? And now, I mean, what could happen is that if ints L0 is smaller than or equal to ints I, no, the other way around. And now if the end of found is in check, that's just the edge case, so that because technically none of them could end at worst when we start. So if this holds, then dpi max dpi dpl +1, right? And then dpi max dpi minus 1, and this should work, I think. Oh great, let's see. Okay, it works, should run fine. Fair enough, but it is extremely slow. So I guess you can do it in linear time. I don't know, what the hell. What is that? Why is it so slow? I don't understand. Oh, because I'm copying it. Ints intervals, replace all. So let's see. I mean, that didn't help. So something is very wrong if everyone else can get it in linear time. Or maybe without binary search, I don't know. Because let's say we have one long block. Do we really want to take the one that ends the soonest? I'm not sure that's the best heuristic, but whatever, right? So int current end is equal to -1 is 6, right? And then auto intervals if interval 0 larger than current and then current taken is this, so current end plus equals, or like, yeah, interval 1 this might work. Wow, okay, that's way faster, I guess, or not. Still, so sorting is slow. Are they pre-sorted? Am I stupid? I have to be doing something wrong, man, because this is ridiculous. Are you kidding me? What? Current and if let's see. We'll start is that. Not sure how output is 1, to be honest. Okay, now we are talking. So I just cannot sort in C++. I guess. I don't know. Okay. I mean, nice that I can solve it like this, but whatever. Greedy O n log n. Okay, so if we sort the intervals by ends, always no. Dual problem is finding the maximum number. Can solve a now. So if we sort the intervals by their ends, it's best to take the soonest ending interval and throwing throw away the ones that are overlapping with the currently taken one. This works because this way we maximize the number of intervals we take, and the answer to the original problem is the total number of intervals minus maximum number of intervals we take. Great. This works because if we do not pick the soonest ending one, we might miss out on the optimal solution, since there because picking the soonest ending one does not worsen the solution. ON intervals since we first have to sort them and then we just iterate over them, doing one work for each of them. Okay. Since we only use since and only, okay, fair enough. Goodbye.